Hey, East High Optics Year 1 students, what's going on? Mr. Eckert here. We are in another week of quarantine life. No end in sight, at least in terms of school. As you hopefully have seen, the district has released guidelines for teachers on grading you. So, with that being said, there are 3 possible grades that you can get for each marking period. For marking period 4. 1, pass. You passed the class. You did the work I sent you. You did most of it. You got basically you got a D or above, a D or C. Then there's pass with distinction, meaning you got like a really good grade. You did really well. You were engaged. You did most, if not all, of the assignments. And then there is incomplete. Incomplete means you really didn't do much. Maybe you only did 1 or 2 assignments throughout this whole time that we've been gone. If you get an incomplete, you're not getting an F. You're not getting an F. However, you still, if you want the credit, need to finish the class. I don't know if they're going to allow at some point in the future to have a summer school optics class. Don't think it's going to happen. So you'd have to retake the class next year if you got an incomplete. Or you would have to do something with me or Mr. Conroe, and then we would go in and change the grade from incomplete to passing. Just avoid all that. Stay engaged from home, do the work that I'm sending you, and I will pass you. If you do all of it, I'll pass you with distinction. That way it ensures, 1, you're getting the credit for the class. A lot of people in this class right now need a science credit. That's why they're in optics. 11th, 12th graders, I'm looking at you. If you're interested in continuing with the pathway and you want to take Optics 2 next year, which will be a little different because we have to finish the stuff that we haven't learned hands-on this year in Optics 1. So we're going to have to change Optics 2 a little bit to better suit the needs of the students that really didn't get a fair year 1 experience. But if you want credit for the class, maybe, and I know a few people I'm looking at right now, you need a science credit, this science credit to graduate. Be engaged in the online learning. If you have questions on the material, join the Zoom hours from 9 to 9:30. Monday and Tuesdays. Email me. If Monday and Tuesday at from 9 to 9:30 doesn't work, I will find another time and I will help you. I will support you. I will assist you. Don't just fall off the face of the earth and don't be engaged, because all that's going to happen is you're going to put yourself behind. That is going to happen. Your teachers are going to have the ability to say, this student was engaged enough, learned enough that I feel comfortable passing them. Right? That's all we can ask. So, with that being said, assignment for this week. It is going to be, some of it's going to be review. Remember last week I gave you somewhat a component of a bigger project that you're going to be working on. Well, I want to step away from that, all those optical companies. I'm going to talk about another more detailed look at a thing that most, if not probably all of you have done in the lab, and that's making divots using spherometers. So this, if you notice, is called the lens making masterclass. And I'm going to make this a little bigger for all of us to see. Lens making masterclass. So what we typically did with year one kids is you get exposed to a manufacturing process in the beginning of the year, middle of the year, and then we take a step out of the lab and we say, all right, let's take a deeper dive and look at really what's going on when you're doing a certain task. Well, Mr. Connor and I have been referring to these as lens making master classes, if you will. Really understanding the concepts of what's happening with the glass and the tooling when you're doing it. Now, so many times in any industry, but specifically optics industry, and my wife who works for Paychex, she talks about individuals that just want to learn a process and repeat it. And they don't ever want to understand what's happening. So that way, if there's a problem or something out of the ordinary doesn't happen, you know what happened and how to fix it. Too many people nowadays, I think it's the digital learning, want to just master a repetitive process and repeat that without ever thinking about what they're doing. I'm trying to get you out of that. I want to make you more marketable as an employee. I want to make you more versatile. So that way, when an employer sees, this individual is a problem solver, I'm going to give him a better job, pays more money. So this is a deeper dive at making divots using spherometers. Remember, you make a divot. You take a little piece of, you take a piece of glass, you make a little, you dig out like a bowl on the surface of the lens, and that has a specific depth that we want. So I'm going to take you through basically just what's on here and then show you the questions for this. Now notice, I did you the favor. You're welcome. After every title for a section, I put what questions are answered in this section. So if I look at my question sheet right here, it says answer the following questions after reading the corresponding reading in Google Classroom. I'll just look at number one. What does the number of grit size tell us? Well, in the reading here, questions 1 through 3 are answered, right? The first sentence, recall the number of grit refers to the size of each particle roughly in units of microns. Another way to explain this is to say 20T is composed, I'm going to change that, of particles of aluminum oxide that are all no bigger than 20 microns in diameter. So that's what that number means for the type of grit. So if you have 30T grit, all the particles in there are about 30 microns wide in diameter. Remember, these tiny little rocks on a microscopic level of aluminum oxide. That's what removes the glass when you grind. It's not the metal that's removing glass, it's the actual particle of aluminum oxide. On 30T or 20T, that number refers to the size and diameter of the tiny little rock, if you think about it, right? So we're going to talk about the grit type you use, why you use that grit type. The next section, questions 4 through 6, talks about the tooling we use. Remember, this is that tool that we use. It's a very short radius tool, and there's a reason that we use a tool that has such a short radius. Questions 7 through 9 talks about the anatomy of a spherometer. So when we make these divots, remember there's the tool, everything that you do in optical manufacturing. After you do the process, there is a tool that you use to measure and verify that you've done that process correctly. Well, for making a divot, that tool is a spherometer. Remember, spherometers have all these different parts. There's an anatomy to them. That's asked in a question. What are all the parts of a spherometer? Look, we have them all laid out for you. All the parts of a spherometer are on this diagram. The next section talks about how does it work and what does it measure. Remember, what does that spherometer do? What does that little indicator tip do when you push it up or you let it go down and you reference it to a surface. So I reference a spherometer to a flat surface, to whatever value I want. I now know that when I go to put it on something else, I can measure that surface relative to what I set it to, that flat surface, right? So for a convex lens, that indicator tip's going to go up. And for a concave, it's going to go down. And then finally, questions 13 through 20 are going to be really taking a closer look microscopically at divots. Notice we have a lot of really good diagrams here that almost blow up the surface. These diagrams were made by hand by a one Mr. Conroe. So this isn't something that we've gotten out of a book. We make all of our own resources in optics. This is made for you. So look at that. On a microscopic level, you see all these little imperfections in the surface, and then you see, whoosh, there's the divot, right? You can tell what that divot is. Recall what these little imperfections are referred to as. We call these, and it's a question, I'm not gonna tell you what number, but we call that subsurface damage. The reason it's called subsurface damage is because when you look at a piece of glass, it looks smooth. Unless you see an actual chunk taken out of the glass, that's nice and flat or smooth surface. You can't, with the naked eye, see all the little imperfections. So we call it subsurface damage because you really have to look at a microscopic level to see what's going on with that surface. Why isn't it transparent? Subsurface damage. So there's all these different sections where we look at a divot microscopically. Then we look at why the depth of a divot doesn't necessarily have to be even, but you have to find the deepest spot of the divot. Remember that. You could have a divot that's all over the place, right? But the deepest spot is what we care about. And everywhere you look, you're going to see that magic number, 150 microns, 150 microns. That's that magic depth that we want. And then this last part talks about you have 150 micron depth divot. Now, I want to get that part ready for polish. Remember, a divot is just a visual marker that you create with 12T grit. So that way when you're grinding later and you're removing that bad subsurface damage that doesn't allow us to polish properly. So if I take a lens that has tons of subsurface damage, I took it right off the curve generator, and I try and polish it right away. That thing's never gonna polish. You're always gonna see lines and imperfections in it. You could polish it for a week. I don't care, it's not gonna polish. It's because of all that damage that the tool created from the curve generator. So we take that, we make a divot in it about 150 microns deep because 150 microns is about the depth of the damage that's created by the tool from a generator. So then when we make that divot, we know, okay, we have this divot that's a known depth with our spherometer. And if we remove that divot precisely, I know that I've removed all of that bad damage, and there's only nice fine little damage left to polish my optic. And we put that in here. So this is the original divot on the left here with all that nasty subsurface damage. When you grind it with 20T grit first, because remember, just like sandpaper, you want to use the coarser stuff first and then work your way down to the fine to make a nice surface. You start with a bigger grit. We start with 20T grit. You could use 30, but then you'd have to go 30, 20, 12. It's a 3-step. We'd rather make it 2 steps. So you got 150 micron divot. You grind it with 20T, and ideally you want to have 50 microns left. So as you grind a part with 20T grit, you check. What's that tool you use to check with? Spherometer, right? You use that spherometer and you check the depth as you grind. And once that depth, the deepest point that you can probe, gets to 50 microns right here, I'm going to switch my grit type to 12. So I've removed 100 microns in this process of the overall surface, because as you remove the overall surface, that divot's going to shrink because you're removing glass from outside of the surface. So now you have a 50 micron divot and you're going to grind with 12T. We don't need a spherometer anymore, because if you marker in that divot and you grind your lens, eventually that divot's going to get smaller, 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 smaller until it disappears. And that's why we marker in the divot, so we can visibly see it disappear. It's gone. Now we have a 0 micron divot and a very, very smooth surface. It's not transparent yet. It's not perfect, because we still have to do one more step, and that's polish it, right? So you have this amazingly put together resource that we made for you. And here are the 20 questions that correspond with it. Do the work, get the credit, gain the knowledge. Don't let this situation rob you of your education. Empower yourself, get the work done. If you need help, I'm here for you. Mr. Conroe's here for you. You can ask me questions if you're Mr. Conroe's student normally, and I'll do my best to answer them. But when it comes to grade stuff, if you're asking me about your grade and you're technically in Mr. Conroe's class, you have to ask him about that, or I have to defer that question to him, because I don't have access to you in the grade book. He's the only one that can give you that grade and evaluate you. Now, him and I talk on a daily basis, too much. Everyone knows Mr. Conroe can talk, right? I can talk too, but Mr. Conroe even more than me. We talk all the time, always on the phone. We're always talking about who's done work in his class, and there's only been a few students. So hopefully with the news that came out and how we're going to be evaluating, that changes and we get a way bigger increase in student engagement online. All right. Stay healthy, stay safe, and we'll see you next week. Bye.